my name is Redo Meyer and I'm the tech lead for Google's Android Developer Relations team. This efficient data transfers Devbyte focuses on how you can use prefetching to implement the big cookie model of efficient data transfers and improve your app's user experience by reducing latency and improving battery life. In previous efficient data transfers Devbytes, I looked at the cell radio state machine and examined ways to analyze apps' data transfer profiles to uncover anti-patterns such as these short intermittent peaks and consecutive but non-overlapping downloads. Having discovered potential problems in this episode, I'll look at how to use prefetching to solve some of them. We know that carriers adjust the timings of cell radio state machine to compromise between data transfer latency and battery drain, but within our app we want to create the perfect user experience that actually sits here, at the sweet spot of non-existent latency and virtually no battery impact. Is such a thing even possible? Yes, it is. Prefetching offers the best of both worlds, an effective way to reduce battery drain by reducing the number of data transfers and minimizing the in-app latency triggered when users have to wait for downloads to complete before performing an action or viewing data. By downloading all of the data that they're likely to need for the current session in a single burst over a single connection at full capacity, you can significantly reduce the number of radio activations. Your challenge is figuring out what you need to download ahead of time so that you can present the user with exactly what they need when they need it, without simply downloading everything and wasting battery power and bandwidth downloading data that's never used. How aggressively you prefetch depends on the size of the data being downloaded and the likelihood of it being used. As a rough guide for a typical cell radio connected over 3G, you can prefetch around 6 seconds. That's about 1 to 2 megs worth of data, if that data has a 50% chance of being used within the current session. Now at that point, the likely cost of downloading any unused data matches the potential savings loss by not downloading that data to begin with. But of course, not every network transfers data at the same rate, so the equation will change based on the speed of transfers and the efficiency of the cell radio technology. This code sets a default value for 3G networks and increases or decreases the size of the prefetch cache based on the speed and cost of each network. Note that we want to prefetch significantly more data on faster 4G networks, and that's both to account for the larger amount of data that can be downloaded within the same time period, but also because the higher battery cost associated with these radios. So that makes it even more important that we avoid extra straight transitions whenever we can. But if networks are different, so are our apps. And as the likelihood of the data being used increases, so does the amount of data it's worth prefetching. So it's important to understand both what data your users are likely to use and what your app's average session length is. A good starting point is to expect session lengths of around 2 to 5 minutes, so large downloads such as video files should be downloaded in chunks at regular intervals. Using the same logic for a music player, it would be good practice to maintain a buffer of one song in addition to the one already being played, rather than prefetching, say, a whole album or playlist. This mitigates the risk of wasting significant bandwidth and battery life if your user stops listening halfway through a song. You can take a similar approach when streaming by using HTTP live streaming, which transmits audio in bursts rather than maintaining a continuous stream that will keep the radio constantly active. If we look at something like a news app, things get a little more complicated. A typical use case for a music player is to find an album or playlist, hit play, and then listen. So you have a really good chance of knowing what's coming next and a reasonable expectation for what your user is going to do. And they're going to have a reasonable expectation that there's going to be a startup latency if they select a new track. Now in contrast, the browsing path when you're using something like a newsreader is much less predictable, with readers potentially swiping between dozens of different categories and jumping between hundreds of articles. In many ways, a newsreader behaves a lot like a browser, so your approach to prefetching can utilize some of the same techniques browsers use to improve speeds. Now, the most naive solution is to download the headlines for a category once it's been selected, and download the related thumbnails when they scroll into view, and then each of the articles once it's been clicked. Now, this forces the radio to remain active for basically the entire session as you're switching categories, scrolling headlines, and reading different articles. And as a bonus, each click is going to have that latency associated with it as it has to download and process and present the data that you've selected. A much better approach is prefetching a reasonable amount of data at startup, prioritizing the first set of news headlines and thumbnails which are likely to be displayed, and continuing on with the remaining headlines and thumbnails, and also article text. Now it's also important to ensure that your prefetching doesn't delay the app startup by making the app wait for the prefetch to complete fully before letting the user interact. The worst example of this is apps that display a splash screen until a ping or download or process cycle is completed. So be sure to process all of your downloads in the background using intent services and libraries like Volley to help process that data progressively and concurrently, and therefore minimize that startup latency. The real trick is being able to accurately guess which articles each user is likely to read and prefetch only those. Now, one approach is a breadth-first search, assuming that users are more likely to read articles near the current one, or you can go depth-first and bank on them reading lots of articles on a given topic. Now, a better approach is to use science. Measure how your content is actually being consumed and use that to inform your decisions dynamically and on a per-user basis. You can start by keeping track of the metadata associated with the content read by each user, such as the categories or authors. You can widen the scope further by incorporating the content that their friends use by integrating a social graph like Google+. And finally, you can aggregate all of this information together across all of your users and discover what's being used by a lot of people. Now, taken together, you can form a sophisticated picture of typical and expected usage patterns of your app, customized for each user. And that allows you to make an intelligent choice over which data you should prefetch. If that all sounds like a bit too much work, then for some apps it may even make sense to simply prefetch everything, effectively providing support for a fully offline experience. This can be really effective for apps with data that doesn't change very often, such as magazines, but you risk spending significant bandwidth and battery life downloading content that's never used. So it should be done with caution. One way to mitigate that cost associated with downloading more than 5 minutes worth of data is to schedule the download to occur at a time when bandwidth and battery life isn't as important, specifically when the device is charging and connected to Wi-Fi, as determined here by using the Connectivity Manager and Battery Manager. And as long as you're monitoring the device state, why not take it a step further and track the current activity of the user? Using the new location-based Services Activity Recognition API, you can modify the aggressiveness of your prefetching based on what the user is doing. In this example, we're going to increase the amount that we prefetch when the user has the app open and is standing still. The assumption being that they're more likely to be browsing articles while stationary than if they're riding a bike. Now, so far we've talked about the case where the app is active in the foreground, but it's worth considering the background case too. Should we prefetch data when the app is in the background? Well, generally speaking, it's better practice to delay your downloads until the app is open, though this will increase your startup latency. A good approach is to use Google Cloud Messaging to notify your app of updates available on the server, and that eliminates the need to poll to check for updates and provides a channel to notify your app of exactly what it should be requesting at startup. Typically, you'll use GCM as a way to initiate client-side notifications without the app needing to initiate a separate download, but where it makes sense, you can use this same mechanism to trigger background updates. I'll cover GCM in more detail, as well as topics including batching, bundling transfers, and using sync adapters in future episodes of the Efficient Data Transfers Devbytes series.